Okay, so special angles and corresponding points on the unit circle. So this thing here, you need to memorize it, right? But you need to know all of these special angles off by heart. Be able to just pretty much like this. Have to recall them, and that goes for 30 and 31. Okay, so if you're going into 31, don't forget all of this stuff that you're about to learn now. You just have to know that the sine of pi over 2 is whatever the sine of pi over 2 is, right? The cos of 3 pi over 4 is this, etc. Anyways, a circle is defined by a set of points that are equidistant from a fixed point called the origin of a circle? What's the middle of a circle called? The center. And being as we are Canadian, we will spell it properly. C-E-N-T-R-E. The distance between any point on the circle and the center is called the radius. A circle of radius r and center 0, 0 is shown below. The point xy lies on the circle. Draw a right triangle in a convenient position and use the Pythagorean theorem to find the relationship between x, y, and r. So the easiest way is to drop a perpendicular line down to the x-axis. Join this, call this x, call this y, call this r, and what are the relationship?
Y squared.
Is the relationship?
Yeah, sort of not a good one. So x squared plus y squared is equal to r squared. The equation of a circle with radius r centered at the origin is... It's the exact same thing. Just x squared plus y squared is equal to r squared. Okay, because this circle is centered at the origin. It means we don't do conics anymore. You don't have to worry about translating that circle or stretching it into a bigger or smaller circle, or an ellipse, which is just a circle stretched more in one direction than another direction. We don't do any of that. The equation of a circle with radius r centered... We just did that, right? No. I think this is just repeated for purposes of having that in front of us. Write the equation of a circle centered at the origin with radius 5 units. So what would we write? X squared plus y squared equals 25. So we could write 5 squared, but we can always square the 5. I expect you to do arithmetic when necessary. Like, don't give me roots of x is equal to 1 plus or minus 2 over 3. But you can actually work those out. They're nice little fractiony numbers. A root like x equals 2 plus or minus root 5 over 3, fine, you leave that. But anyways, write the equation of a circle centered at the origin with radius of 1 unit. What will that be? Big reveal, 1. A circle centered at the origin with a radius of 1 unit is called the unit circle. Okay? So it's going to become a very important thing for us, the unit circle. So a circle centered at the origin with a radius of 1 unit. Why is that so important? Okay, the following points lie on the unit circle in the indicated quadrant. Determine the exact value of the missing coordinate. Okay, so it's the unit circle, so what do we know about the unit circle? What's the radius?
1.
Okay, so the radius is 1. This is a quadrant 1 angle. And we know that x squared plus y squared is equal to r squared, right? So, which in this case is 1, so it's a unit circle. X squared plus y squared equals 1. What do we have a value of? Got an x value. So the root of 5 over 4 quantity squared plus y squared is equal to 1. And here's the question. In quadrant 1, what do we know about y?
Positive.
Positive, right? Because we're going to get y squared equals, so y is equal to plus or minus the root of but we're in quadrant 1, so we know we want the positive square root, right? Like when we get there. And we're almost there. Okay, so what is root 5 over 4 squared? So y squared is equal to 1 minus 5 over 16. What's 1 minus 5 over 16? So 11 over 16, and what is y? Root of 11 over 4, right? Because we could do the square root of 16. And it's positive because we're in quadrant 1. Okay, so Q1y is positive. In quadrant 2, we're looking for an x value. What do we know? So Q2x is what? Negative. My little abbreviations, plus VE and minus VE. Okay, so I know I'm looking for a negative value, right? Again, we're going to have x is equal to plus or minus the square root. We're going to take the negative one. All right, so same deal, right? X squared plus y squared is equal to r squared. R is 1, so it's just 1. X squared plus 2/3 squared is equal to 1. X squared is equal to 1 minus 4/9. Right, you're squaring 2/3. So x squared is equal to 5/9, and x is equal to negative root 5 over 3. Why? Because in quadrant 2, the x value is negative. All right. So I mean, you could write, excuse me, x is equal to plus or minus that, and then, but at some point we just have to say we're in quadrant 2. We know that this is true.
Isn't it 4/9? Because 2 over 3 squared.
Yep. So 1 minus 4/9 is?
Oh, okay. Never mind.
5/9.
I didn't see the 1 minus.
Whatever. Moving on.
I didn't see the 1 minus.
Okay. Now we have, in quadrant 3, what do we know about y? Y is negative. Okay, so just keep that in mind. Okay, go ahead, solve this. You should be able to, again, just start with x squared plus y squared is equal to r squared, or 1. Negative root 10 over 4, quantity squared. And make sure you parenthesize that, right? If you're going to square negative root 10 over 4, it has to be in parentheses. Because when you square it, it has to become what? It's got to become a positive number. Okay, so y squared is equal to 1 minus 10 over 16, right? Root 10 squared is 10, 4 squared is 16. So y is equal to, y squared is equal to 6 over 16, and y is equal to negative root 6 over 4. Okay. And you could write that as negative. You can put the negative wherever you like, but I would advise either sticking it in front or sticking it up top, not writing it in the bottom. I find if I write it in the bottom, I will lose it at some point. Okay, and I will be doing a subsequent calculation, and I'll just forget that it's negative. So leading negatives are nice. Okay, last one. Q4, what do we know about x? So x is positive. Okay, here's our little quadrant diagram if we need it. Okay, unit circle, right? It's a special, right? So there's x squared plus y squared equals 1. Negative root 3 over 2, quantity squared. Okay, make sure that's in parentheses. That's 3/4. Now, if x squared is a quarter, then x is really plus or minus a half, right? Always keep that in mind. It's always plus or minus. But in this case, we predetermined that it's in quadrant 4, so the x value is positive. Okay, any questions? Yeah.
The second last step in the quadrant 3 one.
Yep.
What about, like, if we had reduced the fraction at that step?
Oh. So.
It would have been a different answer.
Yeah. So here's what would have happened. So let's see if we have room. So let's say we got y squared is 6 over 16, which we're going to say is 3 over 8. Okay? Which we are then going to say is root 3 over, well, okay, let's go with, so it's the root of 3 over 8, which is root 3 over 2 root 2, and then we're going to rationalize the denominator and end up with root 6 over 4. So you can go there directly by not simplifying, right? So if you look at this, you say perfect square, don't do anything. Don't touch that, just take the square root. Okay, if you touch it, you're going to go to this and through all of this and end up right there where you would have, which is root 6 over 4. Yeah, so sometimes it's, you know, I was like in doing math is somewhat like playing chess. You got to look ahead a move or two, right? Anybody play chess? Yeah. So playing chess, you always want to look ahead a couple, you know, if I do this, then they'll do that, then I'll do this, etc. Right? And the really good people can look ahead a far distance, right? Ahead. And those of us that aren't so good get beat by iPhones. My phone beat me at chess. I used to be somewhat decent in high school, not great, but decent, and then it just went downhill from there. But looking ahead is just sort of like, hey, I got to take, yeah, I can simplify this, but wait a sec, if I just do square root, I can get a 4 down there. Show algebraically there is no value for x such that the point x, root 6 over 2, lies on the unit circle. Okay, so if there were, well, really all we have to do is solve for x, right? And then say you can't do that. So, x squared plus y squared is equal to 1. Does it say which quadrant? No, so in a sense it's saying you're not going to find one, so it doesn't really matter if it's positive or negative because it just isn't there. But let's work it out. So x squared plus root 6 over 2, quantity squared is 1. So this will be 6 fourths. So x squared is 1 minus 6 quarters. So this says that x squared is negative, right? You can't do that. Now in this case I would just leave the 4, right, because you're going to square root it. So that x is plus or minus the square root of negative 2, negative root 2 over 2. Right? And put that in brackets, and then you say you can't do that. Okay, no, sorry, it's the square root of negative 2. Square root negative 2 over 2. Can't do that. Okay, so there's no real solution for x, because you've got the square root of a negative. You have to take the square root of a negative. Okay. Recall. Special angles are standard position angles that are multiples of pi over 6 and pi over 4. The trig ratios of the special angles can be written as exact values. Watch the demo regarding special angles. We kind of did that one, right? Okay. So we have the special angles somewhere, right? Just hang on, let me pause this. You can look through. Okay, so the red, that has an angle of pi over 6, right? And the green, that has an angle of pi over 3. And the blue, that has an angle of pi over 4. Now, the thing is, we're talking the unit circle, right? So if I take this and move it into place here, what's this measurement here? That's equal to 1. So in all of these special angles, the hypotenuse is equal to 1 because the hypotenuse is the radius of this unit circle, right? So the question then is, so then what are these sides? Okay, so what are those sides? So you say something about, all right, so we know that the sine of pi over 6 is equal to, we're back to your unit circle. Okay, wait, well, we could do this from first. Did we look at the special triangles from first principles? Like how we've got a 60, 60, 60 triangle? Or no, that was like grade 11. Okay. All right, so we could do that. Let's look at the 45-degree triangle, right? So pi over 4, 45 degrees, same difference, right?
All right, so we know that these two sides here must be the same, right? Because it's an isosceles right triangle. If that's pi over 4, then this is also pi over 4. So 45, 45, 90, right? Or pi over 4, pi over 4. Okay, so then we know what? We know that a squared plus a squared is equal to 1. Which means 2a squared is equal to 1. And a squared is 1/2. So what's a? Now keep in mind it's a length, so we'll just, well, it's plus or minus, like, depending on where we are. But let's just do here. So a is square root of 1/2, which is 1 over root 2, which rationalized is root 2 over 2. So for this angle here, if we put in an x and a y, it would be root 2 over 2 and root 2 over 2. Okay, because this length here is 1, right? It's a unit circle. And we know that the sine of this angle is opposite over hypotenuse, which will be root 2 over 1, or sorry, root 2 over 2 over 1, and the cos is adjacent over hypotenuse, or x over, well, we've gone away from that, right? So sine is y over r, which will be root 2 over 2 over 1. So we've conveniently made r equal to 1, so that sine theta just becomes equal to y, right? It's y over r, but r is 1, so sine theta is just y. And cos theta is x over r, but r is 1. So this really is, this is sine pi over 4 cos. Sorry, reverse those. So the y value and the x value is cos pi over 4. Okay. So what if we go to this triangle here? So there's theta, it's pi over 6. So we know that the sine of pi over 6, well, how do we do this? Let's see. Maybe do pi over 3. There's an equilateral triangle, right? Which means that all of the angles are 60 degrees or pi over 3, right? So now we split this here. So normally we would call this length 2, and this length 2, and this length 2. So when I cut it in half, so this is 2, then how big is this guy? That's 1, and then that's 2. So 1 squared plus something, this works out to be root 3. Okay, so 2 squared minus 1 squared is 3, and that's root 3. So this triangle, but the thing is, what we want now is, we want this side to be 1. So what do we do to the 2 to get a 1? Divide by 2. So the 1 down here becomes 1/2, and the root 3 here becomes root 3 over 2. So the coordinates of this triangle become 1/2 root 3 over 2. Now, since the radius is 1, and we know that sine is y over r, right, we just forget about r, right? R is 1, so that sine theta is just y. That's the sine of pi over 3, and that's the cos of pi over 3. Okay, and then we did this guy, so all that's left is this guy. So for this guy, we just think, well, this is pi over 6, and if we just go back to kind of SOHCAHTOA, right, then sine is opposite over hypotenuse, which is just going to be 1/2. So the sine of, so we're doing pi over 6 this time, right? So if we go here, all we got to do is flip these sides, right? Adjacent to pi over 6 is root 3 over 2. So that's root 3 over 2. And opposite pi over 6 is 1/2. So that becomes a half up there. So for the pi over 6, the coordinates are root 3 over 2 and 1/2. Okay, so now we can kind of take this, which we haven't even done anything with because we're doing this, and we'll go over to here and we'll go fill this in. Okay? So either I make this small. All right, so let's take our angles. So what's this angle? Where are we going to label these guys? We'll throw them inside. So this is pi over 6. Actually, kind of, let me shrink this a bit so it fits. 100%? A little bit small. 75? Yeah. Ooh. Oh, whatever. Okay, let's start here. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So let's call that 0, comma, 2 pi. Okay, so that's splitting the circle into 4. Let's split it into 8. So what's halfway between 0 and pi over 2? So there are 8 quarters, right? Because it's 2 pi. It's all the way around. So 1 quarter, 2 quarters, 3 quarters, 3 pi over 4, 4 quarters, done that, 5 quarters, this would be 5 pi over 4, 6 quarters, 3 halves, already got that, 7 quarters, and 8 quarters, which is the 2 pi. Okay, so now let's let's split it into 12 pieces, right? So we've done that. So 12 pieces is 1 pi over 6, 2 pi over 6, but how am I going to write 2 pi over 6? 1/3, right? Pi over 3. 3 pi over 6, okay? So 4 pi over 6, but 4 over 6 is 2 pi over 3. 5 pi over 6, which just is what it is, because it's not reducible. 6 pi over 6, so what's here? 7 pi over 6 down here. 8 over 6, but that's 4 over 3, so that's 4 pi over 3. 9 pi over 6. 10 pi over 6, what's 10 pi over 6? 5 pi over 3. 11 pi over 6, which really is 11 pi over 6, right? Because you can't reduce that. And then 12 pi over 6. Okay, so somehow we count our way around the unit circle, right? And you go 0, half pi, 1.5 pi, 2 pi, etc. Now we can put down the point. So on the unit circle, what are the coordinates of this point? So your x value is 1, because you're out, but there's no, so you're at 1, 0. What are the coordinates of this point up here? So your x value is 0, 1. So this is 0, 1. Okay, so you have to memorize this unit circle, right? Here's how you do it. You need to know 5 numbers, and 3 of them are 0, 1, half, and 1. So those numbers should be pretty familiar, right? So here's what you do. You just count, take the y values and count from 0 to 1. Here are the 5 numbers in order. 1 half, root 2 over 2, root 3 over 2, and 1. So 0, a half, root 2 over 2, root 3 over 2, and 1. So you got 2 new numbers to learn, root 2 over 2 and root 3 over 2. And then I go from 0 to 1, and I count up again, but I'm going this way, right? So I'm counting up, but I'm going down. So 1 half, root 2 over 2, root 3 over 2, and 1. Okay, so if you can count from 0 to 1 by going 0, a half, root 2 over 2, root 3 over 2, 1, right? That's easy to figure out which point is 1, 0, and which point is 0, 1. And you just got to know it goes pi over 6, pi over 4, pi over 3, and then pi over 2. And really, for purposes of getting any exact angles, that's all I memorized, right? I can't be bothered learning the whole circle. If you've got the circle in front of you, and by the way, feel free on a scrap piece of paper to draw the unit circle, right? So like on the back of your bubble sheet or something, you can do the full unit circle. When you get decent at it, it should take you about 2 or 3 minutes at most to draw this, right? So you can sit down and test, I'm doing the full unit circle, okay? But all you need to know is the first quadrant of the unit circle, reference angles, and the cast rule. Okay, that'll take care of everything else for you. Right, so if I have to do the sine of 5 pi over 6, I just say it's quadrant 2 angle. Sine is positive. It's got the same sign as the reference angle, which is pi over 6. And I already know the sine of pi over 6. right, which is the y value there, 1/2. Okay, so anyways, to do the rest of this, all we have to do is reflect this, right? So if I reflect in the line, or what is that? That's the y-axis. If I reflect in the y-axis, then what happens? The x becomes negative x. What happens to the y? Nothing. So all I do is make all of my x's negative and leave the y's the same. And this becomes negative 1, 0. Okay, so if I've drawn the first quadrant, all I have to do is reflect it into the second quadrant. Saying if the reflection in the line y equals 0, x becomes negative x, there we go. If I reflect quadrant 1 into quadrant 4, what happens? Y becomes negative y, right? So this point here, they're the same point. This is going to reflect down to here. It'll be positive root 3 over 2, but negative 1/2. Be negative root 2, sorry, positive root 2 over 2, and negative root 2 over 2. And this point will be positive 1/2 and negative root 3 over 2. And then if I reflect this down here, the x's stay the same, the y's become negative, or if I reflect this over here, the x's become negative, the y's stay the same. So this becomes negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, negative 1/2, negative root 3 over 2, and this is just the point 0, negative 1. So the cosine is the x value. Remember, it's a unit circle. It's got a radius of 1. So cos is x over r, was just over 1. So the cos of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. Cos of root 4 of so cos of pi over 4 is root 2 over 2, as is the sine. Cosine of pi over 3 is 1/2. The sine of pi over 3 is root 3 over 2. So there's your unit circle. Now, what's tangent? Because we don't have tan on here, right? Like, so from the ordered pair, you can just say it's cos theta, sine theta. Okay, so there's cos. But what's tangent? So tan is y over x. Okay, that's cool because I've got an x and a y there, right? So let me show you the long way. I'm just going to blow this up. So here's the long way. If I want to work out this tangent, I need to take y over x, right? So I'm going to take 1/2 over root 3 over 2, which becomes 1/2 times 2 over root 3, which becomes 1 over root 3, or root 3 over 3, because you're going to rationalize. So that's the hard way. Here's the easy way. Ignore the denominators because they're all 2's. This is just going to flip and they're going to cancel. So just do the numerators. Take this numerator over this, 1 over root 3, and then write it as root 3 over 3. Root 2 over root 2 is 1. Root 3 over 1 is root 3. 1 over 0 is undefined. 0 over 1 is 0. Should use a different color, right? Those are the tangents, and then just reflect across. So this has the same y value, right? But wait, it's y over x. It's root 3 over negative 1. And tangent in quadrant 2 is negative, right? So this is negative root 3. This is negative 1. This is negative. Okay, again, we go 1 over root 3, but then you just think root 3 over 3. And again, playing chess, sometimes you may want 1 over root 3 as opposed to root 3 over 3, especially if you know you're going to divide by a tangent, right? If I'm going to divide by this thing which has a radical in the denominator, then I'm going to end up flipping it, so I might as well just leave it with the radical in the denominator. Okay, and then we go down here. What is it? Y over x. What's y? 0 over 1 is 0. Y over x, xy, so negative 1 over negative root 3. So root 3, this is 1. Remember, tangent is positive in quadrant 3, right? It's y over x, and both x and y are negative. And then this guy is y over x, wait, y, sorry, that's negative root, that's positive root 3 over 3. root 3 over 3. That's 1 over root 3. This is root 3 over 1. This guy is positive root 3. And then these tangents here again, tangent is negative, right? Because you've got one negative, one positive. Okay? So it's tangent is positive in quadrant 1 because they're both positive. It's positive in quadrant 3 because both x and y are negative, right? Tan is y over x. And so here we've got negative 1 over root 3, so negative root 3 over 3, negative 1, and negative root 3. So once you know the unit circle, oh, and then down here this one is undefined as well, because you're doing negative 1 divided by 0, you can't divide by 0. Okay? So if you can or wish to draw out the full unit circle, you can do that. So having the full unit circle just means if I ask you some questions, you can just look it up on the unit circle, right? If I say, what's the tan of 7 pi over 4? You don't have to worry about, okay, 7 pi over 4 is a reference angle of this, that, and the other, right? But that requires basically having drawn the entire unit circle. Okay? I prefer to just draw the first quadrant, right? If I've got the first quadrant, I've got the cast rule, and I've got reference angles, I'm good to go. Right? And that goes back to, I don't know, earlier times, but it was like a couple of days ago, probably. It goes back to just the beginning of the, I think just the beginning of the section when we did that, right? Just said, what's the reference angle? What quadrant are you in? Or, you know, what quadrant are you in? What's the sign in that quadrant? The SIGN sign, and then what's my reference angle? What's my value for whatever? And then I just say it's positive this or negative that. All right, so let's ignore this for a sec. Let's skip ahead to the exercises. Exercises. Okay, so you just for now you can just flip back and forth between the unit circle you have. Okay, so all you're going to do for the exercises is you duplicate the unit circle, then we get asked, so what's the sign of 2 pi over 3? Okay, so you look on the unit circle and you say the sign of 2 pi over 3 is root 3 over 2, right?
I think you skipped.
I did. I skipped to the exercises.
You did?
Keep going. Go to the exercises. Go forward. Go forward. There you go. What's the sign of 2 pi over 3? So just flip back to your unit circle and say, what's the sign of 2 pi over 3? Root 3 over 2, yeah? What's the sign of 7 pi over 4? What's the sign? Now I'm not looking at anything, right? Here are my answers, right? They are now underneath. Okay? I just want to show you. I'm not looking at anything. This is what you have to know. What's the sign of negative pi over 2? What's the sign of 240 degrees? So on your unit circle, you may want to do degrees as well. Okay, so go like 30 degrees, comma, pi over 6. 45 degrees, comma, pi over 4. 60 degrees, comma, whatever. Okay, now, here's how I do this. Because I only know, here's all I know. I know nothing. This is all I know. And I know that this is the point 1, 0. This is 0, 1. There are 3 angles in here, one of which is pi over 3, then pi over 4. Sorry, this is pi over 6, then pi over 4, and pi over 3. And I know how to count from 0 up to 1, so it's a half, root 2 over 2, root 3 over 2, and 1, and 0 to 1 going this way, and 1. And I know that this is 30 degrees, 45 degrees, and 60 degrees. Okay, so there's only one thing I know. I know the sign of 30 is a half. I can actually get the rest of it from that. Here's how that works. The sign of 30, which is pi over 6, is a half. These guys added up and squared have to equal 1. Okay, so this a half is paired up. It's really a half goes with root 3 over 2, wherever it is. And root 2 over 2 goes with root 2 over 2, and 0 goes with 1. So if I know that the sign of 30, which is pi over 6, is a half, then I know that the first coordinate is root 3 over 2. And for 60 degrees, they're reversed. Do you know what cosine means? Cosine? You know what the co is? It's this. Complementary. What's the complementary angle? Adds up to 90. So, what adds up to 90 with 30? 60 degrees. What's the cosine of 60? It's the sine of the complementary angle, so the cosine of 60 is the sine of 30. The cosine of 30 is the sine of 60. Huh? That's how that all works. So if I know the sine of 30 is a half, I know it goes with root 3 over 2, I know they get flipped for 60, and I know these guys are the same, and the only number that's the same is root 2 over 2. So here's how I do the sine of 240 degrees. 240 is in quadrant 3, the sine is negative, the reference angle is 60, 60 degrees, negative root 3 over 2. Sine of 3 pi over 2, that's quadrantal. I actually do that slightly differently. I imagine the graph of the sine function in my head. We're not there yet. But that's just going straight down, so the y value is negative 1. Cos of pi over 3, that just is the cos of pi over 3, right? Which is not the sine of pi over 3, and not the sine of pi over 3. Pi over 3 is 60 degrees. 60 degrees, not the 30, so you've already got that. But that's easy to draw out, right? Like you can draw that on a test. So then pi over 3, what is the sine? It's 1/2, right? 210, the cos of 210 is in quadrant 3, so it's negative. Its reference angle is 30 degrees, right? 180 plus 30. So you really have to be up on, if you want to do it this way, you really have to be up on your reference angles, okay? So, cos of 210, it's quadrant 3, it's negative, it's the same as the cosine of 30 because that's the reference angle. Cos of 30 is root 3 over 2, negative root 3 over 2, right? Etc. Let's just do one down here. The tan of 7 pi over 4. Okay, 7 pi over 4 is in quadrant 4 because 8 pi over 4 is right above it. It's the same as the tan of pi over 4 because that's its reference angle, but it's negative. The tan of pi over 4 is 1. So that's negative 1. Okay? The cotan of 3 pi over 4. I'm just going to work out the tangent of pi over 4 and then flip it. It's still 1, but... the secant of negative 7 pi over 6. I'm going to work out the cosine. First of all, it's a negative rotation angle. So it's in quadrant 2. Its reference angle is pi over 6. The secant goes with the cosine because there's one co per pair. The cosine of pi over 6 is root 3 over 2, but it's in quadrant there, so it's negative root 3 over 2, but it's flipped, so it's negative 2 over root 3, which I shall rationalize in my head to negative 2 root 3 over 3. Okay, anyways, that's the degree to which you shall aspire. You might never get there because you don't teach this stuff for a living, but you need to be able to get there relatively quickly. Okay? So you need to know, and this is how I do it, right? Because I can't be bothered writing down the whole circle. Okay? So I use the first quadrant of the unit circle. I count from 0 to 1. Just remember 5 numbers, right? 0, a half, root 2 over 2, root 3 over 2, and 1. And then I count this one going 0, a half, root 2 over 2, root 3 over 2, and 1. I look at my angle. I figure out which quadrant is it in. What is its reference angle? Okay, well, which quadrant is it in? Therefore, its sign is blah, positive or negative. What's its reference angle? Then I look at my quadrant 1 thing and just figure out, okay, so then the cosine of this is that, but it's in this quadrant, so it's negative. Way you go. So for filling this in, you can use the full unit circle, right? Which you're going to duplicate up there. Okay? And you can draw that unit circle. You could sit down on the diploma, take out one of the tear-out sheets, draw the unit circle, right? I mean, if you've practiced it by then, I mean, it just means seriously you got to sit down and draw out about 20 unit circles, over the course of the next weeks, months. So you can just sit down, take a sheet of paper, 0, pi over 2, pi, 3 pi over 2, 1, pi over 6, pi over 4, pi over 3, 2 pi over 3, etc., right? Fill that in, count up 0 to 1, reflect it into that quadrant, down to there, and then over to there. Here's my full unit circle. Ask me anything, you can say, right? It doesn't matter what it is, I can figure it out. If it's negative, I just rotate the other way. Okay, anyways, that's the aim. So the aim is to be there. But now we're here. Okay, so going back here. It's going to take you time at first. That's fine, right? So fill in the full unit circle. For now, fill in the full unit circle. Use it to get all those answers. Check the answers, right? Because I think the answers are somewhere in there. Okay, so your answers for the exercises are there under the word answers. They're all there. Okay, so not for number 2 because really you should not make mistakes with 1 or 2. But oh, and so hang on. We'll come back to this. So we'll do this, and then we'll come back to the exercises, and we'll just look at like 3 and 4. Okay, is that fair? We'll do that. We'll go out of order. If theta is a standard position angle, the function p of theta assigns theta to the point on the unit circle where the terminal arm intersects the circle. So in other words, p of pi over 6 is root 3 over 2 comma 1/2. Right? P of pi over 4 is root 2 over 2 comma root 2 over 2. P of 2 pi over 3 is negative 1/2 comma root 3 over 2, right? So P is just the point, so P of pi over 3. What's P of pi over 3? It's like root 3 over 2 and 1/2. So you can look at your unit circle for now, right? So you get used to it. That's wrong.
Yeah.
That's how good I am. That's wrong. It's good though. See? Because you're saying, wait, that's wrong. P of negative 5 pi over 6. Again, you're looking at your unit circle, but you're going to rotate. Or do the coterminal angle. So add 2 pi. Not 2 pi, add 12 pi over 6. So P of negative 5 pi over 6 is the same as P of 7 pi over 6. They're coterminal, right? So they have the same terminal arm. So it's in quadrant 3. Its reference angle is pi over 6. I'm starting to look. But in quadrant 3, both x and y are negative. So this is negative root 3 over 2, negative 1/2. Okay? And on yours, you would just either rotate negative 5 pi over 6, or you would go to 7 pi over 6. Look at the point on the unit circle, right? Because you have a unit circle in front of you. 270. So that's like straight down, right?
Yeah.
So that's no x and 1y down. So 0, negative 1. 13 pi over 4. What's that the same as? 5 pi over 4, right? So you want a coterminal angle, right? So 13 pi over 4, you got 2 choices, right? You could just go, okay, like 1 pi over 4, 2, 3, 4, 5, 6. There's 8 pi over 4, 9, 10, 11, 12, 13. Okay, or 5 pi over 4. Okay, so you say we're down here, everything's negative, and it's anything with the pi over 4 is just root 2 over 2, right? But in this case, they're both negative.
Okay.
Okay, so the pi over 4s are easy. They're all just root 2 over 2 and root 2 over 2, and depending on which quadrant they're in, they're both positive or both negative or one of each. For each of the following, state values of theta and beta, or theta and beta if you're actually speaking Greek, such that theta is between negative 2 pi and 2 pi. So we got to do some coterminal stuff. And beta is between negative 360 and 360. Okay, so if the angle has the xy coordinate, negative root 2 over 2 and root 2 over 2, which quadrant is that in? The quadrant 2, right? You have a negative x and a positive y. So you got a quadrant 2 angle. So which angle has that? 3 pi over 4. Okay, but we need between negative 2 pi and 2 pi. So what's the other angle? So 8 over 4. 8 pi over 4 is going to make it coterminal.
Yeah.
So what do we want to do with that 8 pi over 4? Add, subtract? We're going to subtract, right? Because we got to go negative 2 pi. So remember, in this case, we're really going from negative 8 pi over 4 to positive 8 pi over 4. Okay, so I'm going to subtract, and get, so let's put them in order, negative 5 pi over 4 and 3 pi over 4. Okay, and those are coterminal angles, right? So theta. And as a matter of fact, let's throw in some set notation. So let's say theta is the set consisting of the numbers negative 5 pi over 4 and 3 pi over 4. Negative a half, negative root 3 over 2. Which quadrant if it's negative? Think quadrant 3. Okay, so I need the quadrant 3 angle. So which angle has a half and root 3 over 2? So I just look over here and say, okay, it's pi over 3. That's my reference angle is pi over 3, but we're going to be down in quadrant 3. So what's my angle? 4 pi over 3. Now let's throw that down second, because the first angle is a negative coterminal angle. So you want to subtract what? 6 pi over 3 and get negative 2 pi over 3. Okay, so we'll just go with the idea of coterminal, right? And since the denominator is 3, then 2 pi becomes 6 pi over 3, right? So I would add or subtract 6 pi over 3. So in this case, the principal angle is between 0 and 2 pi, and then I know I need to go negative, so I'm going to subtract. Okay, beta is in degrees. Negative 1, 0. So where's negative 1, 0? This doesn't sort of fit on here, right? But it's over here. So how many degrees is it over here? 180. That's the positive angle. What's the negative angle? So it's negative 180 and 180. So right now you're going to add or subtract 3. Well, in this case, we're just going to subtract 360, right? Because we're always going to go for the positive angle. Okay, root 3 over 2, that's here. That's 30 degrees. Okay? And then what is it as a negative rotation? So if I start here and rotate, it's going to be negative 330. So negative 330. Oh, wait, sorry, that's negative a half. So which quadrant is that in? We've got a positive axis, and that's quadrant 4. So it's 330 degrees, so that'll be the positive angle. And then negative 30, right? We'll just subtract 360. Okay. So we'll just go with, go with the principal angle, 330, and then just go with the coterminal angle. In degrees, subtract 360. Here, subtract 2 pi, but do it in the form of 6 pi over 3, right? Here, do it in the form of 8 pi over 4. Okay? If P of theta is AB, then what's P of negative theta? Complete each of the following. Okay, so let's just draw in. So here's theta, and it's at AB. So how would I draw negative theta on here? Where would I go? Keep going that way? So negative theta is just theta. So what are these coordinates? A, negative B. Okay, theta minus pi over 2. Okay, or how many degrees would that be if we were doing degrees? Pi over 2 is 90 degrees, right? Now remember, pi is 180. Okay, so pi over 6 is 30. 180 divided by 4, 180 divided by 3, 60 degrees, 180 divided by 2, 90 degrees. All right, first, let's just sketch in a theta. Sketch in a better theta. Okay, so here's an angle theta, and it has coordinates AB. So I want to go theta minus pi over 2. So I want to subtract pi over 2 and 90 degrees, right? So there's a right angle. Yeah, don't draw that like that. I mean, I drew it like it was this one here, and so looking at it, that would be wrong. So let me just clean that up. Put down the red. Let's go with the small theta here. So that's theta. So now I want to subtract 90. I need to make a right angle here. Okay, it's obviously not a negative b, and okay, so what is it? So we know, what do we know? So we look at this, we say, well, I know that this angle here is theta, this angle here is pi over 2, right? Okay, because we went theta and we subtracted pi over 2, which means we are going negative pi over 2 from here. We're going negative pi over 2, right? Minus pi over 2.
What if the theta was in quadrant 2?
Wouldn't matter, then I'd just be going down.
Okay.
Oh, sorry, I'd be going back that way.
Yeah.
So if theta was over here, theta minus 90 just means I'm rotating in a clockwise direction 90 degrees from wherever I am. Okay? Now, the thing that's going to end up true is this, whatever these coordinates are, they'll be the same no matter where you are when you do it. Okay? But we got to figure something out, right? So what do we need to know? So if that's pi over 2, then these two angles here must also add up to pi over 2, right? What's this angle in here? So it's going to be pi over 2 minus theta, right? This angle here. So this angle here is pi over 2 minus theta. So what's this angle here? Theta. Yeah. You see why it's theta? Okay. Let's call it A for now. So here, we'll just say that. Call that A. So what do we know? We know that these two, if this is pi over 2 or 90 degrees, then these two add to 90 because that's 180 or pi, right? So from here to here is pi. This is pi over 2, so these two together, so pi over 2 minus theta plus A must be equal to pi over 2. So I get negative theta plus A is equal to 0. Subtract pi over 2. So then A is equal to theta. So this angle here, that's theta. Okay, so hang on. But this angle here is theta. So let's take a look at this angle, right? So adjacent to angle theta is side A, right? Here's angle theta. The adjacent side is A. Here's the angle theta here. The adjacent side is A, so this is A, but it's going down, so this will be negative A. Sorry, that's going down, so actually the negative A goes here. And the side that is opposite the theta is B, so again, remember, theta is actually in there. So this side here is the B value, which is x, that's our x. So the x value is b, and the y value is negative a. So AB, B, negative a. Okay, so based on this whole thing adds up to pi, that's pi over 2. These two guys together are pi over 2, but this angle is pi over 2 minus theta. So this angle must be theta. Okay, drawn in an awkward place. It's really in here, right? That's theta in here. That corresponds to this theta here in terms of getting the lengths of the sides. Okay? If that's theta and that's theta, the side lengths must be the same. Radius is always 1. This is AB. This is the A, but it's going down, so it's negative A. This is the B, so B negative A. P of theta minus pi is what we're supposed to, so hang on. So there's theta, here's the point AB. Where's negative A, negative B? Well, okay, so if that's A, then negative A is this same distance, and negative B is down here. So this is negative A, negative B. So this is theta minus, so the angle, they add up to pi?
Yes.
So it's theta minus pi. So in this case, really, I guess this angle is theta minus pi, and this is the angle theta. So that's, oh no, sorry, it's the other way around. Yeah. Can't fix diagram. Okay. Wait, let's just keep undoing stuff. That's theta minus pi, and that's theta. Negative AB. Okay, so here's theta at AB. So where's negative AB? Negative AB. So what's this angle? So pi minus theta. Yeah. Now, really, this could be plus or minus pi. Right. So theta plus pi this way, theta minus pi this way. Theta minus pi, that's theta plus pi. Okay. We're done with that page. A rectangle is inscribed in a unit circle with vertices. Okay, so unit circle. Okay, so we got a vertex at pi over 3. So P of pi over 3, P of negative pi over 3, and P, sorry, negative pi over 3 is down here. And 2 pi over 3, which will be here. And negative 2 pi over 3, which will be down here. And it's supposed to look rectangly. So there's our vertices. So what points go with those? So we've got the point, right? This is 1/2 root 3 over 2. This is negative 1/2 root 3 over 2. This is negative 1/2 negative root 3 over 2. And this is 1/2 negative root 3 over 2. So determine the area. So area is length times width, right? So this is length, and this is width. So what's the length? How far is it from here to here? It's like 2 of these guys, right? So the length is 2 times root 3 over 2. And what's the width? 2 times 1/2. So, I mean, although this is negative, it's the distance we want, not that this is negative 1/2. This length is 1/2. This length is 1/2. 2 times 1/2 is 1. This length is root 3 over 2. This length is root 3 over 2. We've got 2 of them. So that's equal to, these guys cancel, these ones, so it's root 3, these guys cancel, so just root 3. Okay, units squared. It doesn't hurt. Okay, we can't put centimeters in there, we don't have any units on there, so it's just units. The unit circle, it's root 3, square root 3 units squared. Okay, so I mean, what are we? We're just using our knowledge of it's the point on the unit circle, so we actually have all of these coordinates, and then we can work out the 2 distances and work out the area. A triangle is inscribed with vertices at pi over 3. Okay, so let's inscribe a triangle. So we've got pi over 3, which is 1/2 root 3 over 2. 2 pi over 3. So there's the center. So 2 pi over 3, which is a reflection of that, right? So negative 1/2 root 3 over 2. And 3 pi over 2, which is down here. Let's label that in here, 3 pi over 2. And its coordinates are 0, negative 1. And there's a triangle. Okay, so what's the formula for the area of a triangle? Yeah, so area is 1/2 base height. So let's call this the base. So how far is it from negative a half to positive a half? 1.
Yeah, one.
And how far is it from here to there? So let's do this. How far is this? So that's 1.
1 plus.
And how far is this? Well, it's root 3 over 2, right? That's 0. So this is root 3 over 2. So the height is 1 plus root 3 over 2. Now, we should express that as a complete fraction. So it's a half. 1 plus root 3 over 2 will be 2 plus root 3 over 2. Right? So this common denominator becomes 2 over 2, becomes 2 plus root 3 over 2. So this becomes, actually, we probably write root 3 plus 2 over 4. Okay, so generally speaking, if there's a radical, you write it first. So you go root 3 plus 2 all over 4. Units squared again. Okay, so draw the points on the triangle, work out their coordinates. How far is this? Well, it's a half plus a half, 1. How far is this? The height? Well, okay, radius is 1, that's 1. And then this distance here is this distance, right? That's 0, 0. How high? It's root 3 over 2. So 1 plus root 3 over 2. Common denominator, add them. And okay, in exercises, so we said we would go look at some other exercises. State the exact value out. Okay, so what we need to know is, what does cos squared of negative 2 pi over 3 mean? This is what it means. Now, it will always be written like this, but this is what you say, it's the cosine of negative 2 pi over 3 quantity squared. So when you see cos squared of something, it says take the cosine of it and then square that value. Okay, plus the cosine of pi over 6 squared. So do the cos of negative 2 pi over 3, get that number, then square it. Get the cos of pi over 6, get that number, and then square it. So the work on here would look at, all right, what's the cos of negative 2 pi over 3? So negative 2 pi over 3 is in quadrant 3. Has a reference angle of pi over 3. So the sine of pi over 3 is 1/2, or sorry, cosine. So it's a half, so it's negative 1/2. Okay, so the cosine of negative 2 pi over 3 is negative 1/2. So this is equal to negative 1/2 quantity squared. Okay, so you do the cos of 2, however you do the cos of negative 2 pi over 3, right? You could do coterminal angles just to add 6 pi over 3, make it cos of 4 pi over 3. Okay, it still makes it negative, just it's the same angle. And then cos squared of pi over 6. So the cos of pi over 6 is root 3 over 2. And then that's being squared. Okay, so when you see sine squared, cos squared, sec squared, tan squared, cotan squared, cosecant squared, any of these guys, it means you do the secant of pi over 3 and then you square it. So in this case, negative 1/2 squared is 1/4 plus 3/4, which is equal to 1. Okay, so this evaluates to 1. He says, hopefully. Check the answer at the bottom. Is it 1? 3b? Woohoo. Okay, so tan squared pi over 6 plus tan squared pi over 3, you work out the tan of pi over 6, and then you square it. You work out the tan of pi over 3, and then you square it. Okay, what should we do? Any more of these? Any more exciting ones down there? So, okay, how about D? Well, we'll just do the first part. So secant squared pi over 3. So you have to get the secant of pi over 3, which means you have to get the what?
Oh.
you have to get the cosine of pi over 3, and then you're going to flip it, right?
Oh, I got it.
So, sec squared pi over 3, you think, I need 1 over the cos of pi over 3 squared. So I need the cosine of pi over 3. Okay, what's the cosine of pi over 3? It's 1/2. I need the reciprocal of 1/2, which is 2. And I'm going to square it, so I get 4. So this works out to 4. Okay, and then you work out the rest of it. Okay, so if you are doing cotan, secant, cosecant, you just figure out, okay, I want the secant of pi over 3, that's 1 over, it's actually not even 1 over, it's just the reciprocal of the cosine of pi over 3. So cos pi over 3 is 1/2, the reciprocal of that is 2, squared is 4. You want the cotan of pi over 2, it's the tangent of pi over 2. So here's pi over 2. Tangent is y over x, which is 1 over 0, which is undefined. So it's undefined, therefore the whole thing. But wait a sec, we want the cotan. So it's a little different, I guess. When you're doing cotan, don't think of it as 1 over 0, which is undefined. Think of it as I got to flip these, make it 0 over 1, which is 0. Okay? Otherwise, you're sitting here saying, I got to square undefined. I need 1 over undefined. Okay, we really can't do that. But if the tan ratio is undefined, then the cotan is 0. Okay, what else is there?
Number I.
Exact values, sine squared. Okay, same deals.
Yeah, everything is easier.
How was I number?
And more questions,
I'm making it a number.
Number.
as well as some textbook work.